Welcome back a second time. You have already heard much praise for our next speaker, Dr. John Holdren, who is the Assistant to the President for Science and Technology and the Director of the Office of Science and Technology Policy, as well as the co-chair of the President's Council on Advisors on Science and Technology. Somehow executive branch titles tend to accrete and grow. Much more importantly, as you've already heard from Senator Markey, Dr. Holdren has been a moving force behind the current administration's policy on climate change, which you probably know is significantly different from that of its predecessor. Dr. Holdren holds advanced degrees in aerospace engineering and theoretical plasma physics from MIT and Stanford. Prior to joining the Obama administration in 2009, he spent 36 years as a faculty member at the University of California, Berkeley, and Harvard, teaching energy, technology, and policy. He's a distinguished member of the U.S. National Academy of Sciences, the National Academy of Engineering, and the American Academy of Arts and Sciences. Additionally, he's a member of the Council on Foreign Relations, as well as a foreign member of the Royal Society of London. Dr. Holdren has been the recipient of numerous prestigious awards, including the MacArthur Prize Fellowship, the Volvo International and Tyler Environmental Prizes, as well as the Heinz Prize for Public Policy. But much more importantly, he is a man of great energy who is a mover and shaker behind the scenes. So, Dr. Holdren, it's a great pleasure to have you here at Boston College today and hear your remarks. By the way, we'll do another round of index cards for Dr. Holdren as well. Thank you very much.
Well, thank you very much, David, for that kind introduction. I'm in danger of losing my voice, so I'm hoping this microphone will be adequate to the task. I'm going to cover quite a lot of ground in these remarks, as indicated here, really linking the science content of the encyclical to the path forward in climate policy, including President Obama's Climate Action Plan. So let me start with the encyclical's embrace of climate science. Early statement in the encyclical, very solid consensus that we are presently witnessing a disturbing warming of the climatic system, and I want to talk a little bit about that consensus. The warming has been described by the Intergovernmental Panel on Climate Change as unequivocal. The National Academies of Science of every major country in the world that has one have agreed with that analysis, and the warming is evident in so many different ways. It's evident in the near-surface air temperatures over every continent, in the sea surface temperature across the globe, in the shrinkage of sea ice, the retreat of the great majority of the world's glaciers, the loss of ice from the Greenland and Antarctic ice sheets, among other indicators. This is the thermometer record for the last 135 years or so, near-surface air temperature as directly measured by thermometers across the world. 2014 was the warmest year in that 135-year record, 2010 the second warmest, 2005 the third warmest, and 2015 is on track to surpass 2014 as number one. We can also infer the near-surface air temperature over much longer periods of time from various forms of what are called paleoclimatological evidence: ice cores, tree rings, fossil pollens, sediments, and so on. This is a reconstruction of the last 1,100 years, and what one sees is something I'll show in a little more detail in a minute. We have been in mostly a long-term cooling trend until human activities reversed that trend around 1800. This just shows the declining mass of the world's glaciers from 1940 to 2010. This one shows the decline in the summer extent of Arctic sea ice at its minimum, which occurs typically in mid-September. On the left is 1984, on the right is 2012. This shows the change in the mass of the the Greenland ice sheet from 2002 to 2014. So that rather strongly supports the initial statement in the encyclical of what's going on. Next statement, A number of scientific studies indicate that most global warming in recent decades is due to the great concentration of greenhouse gases released mainly as a result of human activity. That is, not only is the climate changing, but humans have major responsibility for what is happening. The relevant science, Intergovernmental Panel on Climate Change, extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. And the reason for that is that the observed warming matches with great fidelity what science predicts would result from the greenhouse gas buildup that is known for certain to have resulted from human activity. And let me turn to that. We have no doubt whatsoever scientifically that the key greenhouse gas increases were caused by human activities. You're looking here at 10,000 years of atmospheric concentrations of carbon dioxide and methane, and you see what happened on the right at the time of the Industrial Revolution. It is very hard to look at those graphs and think anything other than that human activities caused those increases, but we know it even more directly because of carbon isotope fractions in the fossil CO2 we've added to the atmosphere versus the CO2 that was already there courtesy of nature. We can compare quantitatively the magnitude of those greenhouse gas increases that we have caused with the known natural influences on the climate over the same period. This is the period from 1750 to 2011, numbers from the IPCC. And you see, and we'll post this PowerPoint so that if the numbers go by too quickly, you can refer to it in your abundant leisure. But of course, I'm kidding. I know that students at BC have no abundant leisure, but never mind. You can see, looking at these numbers, that the warming influence of anthropogenic greenhouse gases has been about 60 times the warming influence of the estimated change of input from the sun over this period. 60 times. It is not the sun doing this, it is humans doing it. The human influences explain the temperature increases on every continent, not just on the global average. Here, the black lines are observations. The blue bands are computer models that include only natural influences. And the pink bands, which you find the black observed lines in the middle of, are the ones that include both natural and human influences. Now, this shows even more clearly than the earlier graph that the human-caused greenhouse gas increases overcame a long-term cooling from natural causes. This is about a 12,000-year record. And again, the sudden switch of the long-term cooling trend, we were actually heading very slowly toward another ice age. Carbon dioxide has saved us from that. Unfortunately, it has saved us a little too excessively. Continuing, the Encyclical. In recent decades, the warming has been accompanied by a constant rise in sea level, and it would appear by an increase in extreme weather events, even if a scientifically determined cause cannot be assigned to each particular phenomenon. Here, the Encyclical actually is a little bit understated. The rate of sea level rise lately has not been constant but growing. It is now 2 times the 20th century average. And the increase in extreme weather, especially but not only extremely hot days, heat waves, and extreme downpours, has now been documented beyond question. This is the sea level chart from 1860 up to 2010. This is kind of interesting. Global average frequency of extremely hot and extremely cold days. The extremely cold days are appropriately in blue, the extremely hot days appropriately in red, and again, the trend is unmistakable: more extremely hot days, fewer extremely cold days. Downpours are increasing nearly everywhere. The reason downpours increase under global warming is that a warm atmosphere can hold more water, and therefore more can fall all at once. Here are just some article headlines from one of the most esteemed peer-reviewed scientific journals in this field, Nature Climate Change. Increase in risk of extreme summer heat in China. Dramatically increasing chance of extreme hot summers since the 2003 European heat wave. Stormiest winter on record for Ireland and the UK. Well, what about storms? Powerful storms are caused by many factors acting in combination, so one can never say that a particular storm was caused just by climate change. But we know that climate change is increasing the power of some of the most powerful storms. The most powerful storms are getting more powerful under climate change. This is a Toll's cartoon referring to this particular point, one of my favorites. So the encyclical, warming creates a vicious cycle, affecting the availability of essential resources like drinking water, energy, agricultural production, leading to the extinction of part of the planet's biodiversity. The science. It is, in fact, well established scientifically that climate change is adversely affecting, and it will continue to adversely affect the availability of water in many regions, the productivity of farms and forests, energy supply and demand, and the distribution and abundance of species, those we need, those we love, and those we hate, like mosquitoes. This is a picture from the UN Development Program Human Development Report of 2006. The black areas show where climate change is adversely affecting and is expected to continue adversely affecting the availability of water. This is from a National Academy of Sciences study of climate change that came out in 2010, showing the expected decline in the yields of various of the world's staple crops, corn, soybeans, rice, and wheat, under various degrees of global temperature increase, 0, 1, 2, 3, and 4, if you can't read the axes. And these declines are without taking into account any increase in major droughts. But droughts are, in fact, expected to worsen. At the top, frequency of 4 to 6 month duration drought events in the reference period of 61 to 1990. The bottom, the result of 8 of the major global climate models in what is to be expected from 2070 to 2099. And all those areas of red and yellow are sharp increases in the incidence of drought attributable to climate change. Extinction risk. The encyclical refers to extinction. Paper in Nature from January 2004, we predict on the basis of mid-range climate warming scenarios for 2050 that 15 to 37% of species in our sample of regions and taxa will be committed to extinction. Climate Change 2014, the Working Group 2 of the 5th Assessment Report of the IPCC on impacts, adaptation, and vulnerability, a large fraction of both terrestrial and freshwater species face increased extinction risk under projected climate change during and beyond the 21st century. And that is a conclusion that they reached with high confidence. Back to the encyclical. Carbon dioxide pollution increases the acidification of the oceans and compromises the marine food chain. The relevant science. Sure enough, the impact of climate change on the productivity of the oceans is one of the biggest sleepers in the climate challenge. Not only does increased atmospheric CO2 lead to increased acidification of the ocean, but global warming also changes circulation patterns. Temperature and currents combined affect the geographic ranges and abundance of species important to both commercial and subsistence fisheries. This shows the historical increase of atmospheric CO2 in red, CO2 dissolved in seawater in blue, and the pH of the seawater in turquoise going down steadily over the period. The impact of acidification is, above all, hard on organisms that form their shells and skeletons from calcium carbonate. This illustrates the difference between ordinary and acidified ocean water in its effect on pteropod shells, an important species, an important class of organisms in the marine food web. And this next slide compares 1870, 2003, and 2065 in terms of the ocean conditions supportive of coral reef formation. The red and the yellow are regions that will not support the building of reefs by warm water corals, And what one sees is that such reefs could be dead or in peril over most of their ranges by the mid to late 21st century. Back to the encyclical. If present trends continue, this century may well witness extraordinary climate change and an unprecedented destruction of ecosystems. A rise in sea level can create extremely serious situations, and it goes on. The relevant science. I would argue, again, it's a bit understated in the encyclical here. The magnitude of human-caused climate change is already extraordinary. It's already having significant impacts on society and on ecosystems. And continuation of present trends, as the encyclical says, would certainly, almost certainly, mean unmanageable impacts of climate change, really a disaster. First of all, the proposition that harm from climate change is already widespread around the world. We're seeing variously increases in all of these phenomena: floods, wildfires, droughts, heat waves, pest outbreaks, coral bleaching, the power of the strongest typhoons and hurricanes, the geographic range of tropical pathogens, and all of these are plausibly linked to climate change by theory, by models, and by observed fingerprints of climate change in the resulting impacts. Look at business as usual, where we're going. This graph goes out. The first dotted line is 2000, second dotted line is 2100. The graph goes all the way to 2300. The red curve is the business as usual curve, one that the IPCC called RCP 8.5. That refers to the number of watts per square meter average disruption of the Earth's energy balance at the maximum. The RCP3 PD is a stabilization scenario in which we would stay below an increase of 2 degrees C, the goal that the world has embraced. And you see that that business as usual scenario is basically leading to a roasted world, the vicinity of 8 degrees C above pre-industrial levels, and that's just the global average. Mid-continent increases would be much higher. Increases in the Arctic would be much higher than that. One of the things that happens under business as usual is severe heat waves continue to multiply. And this somewhat busy graph says a very important thing. In 2003, there was a heat wave in southern Europe, France, Spain, and Italy, that killed between 35,000 and 70,000 people, reduced crop production by about 30% in the region. That heat wave, which was a 1 in 200 year event under pre-industrial climate change conditions, estimated to be about a 1 in 100 year event under conditions prevailing at the time. The probability had doubled. That heat wave will be normal, occurring about every other year in 2040, and by 2060, those summer conditions in southern Europe will be an unusually cool year for the region under business as usual climate change. The encyclical talks about sea level rise. This shows color-coded the risk to a number of the world's coastal regions, yellow verging into green being the worst, but red being the soonest to occur. It's a little hard to see on the global level, so let me show you. This is just a 1 meter rise for the northeastern United States. The red areas are areas that would be flooded at high tide under a 1 meter increase in sea level. And this one is the same for Louisiana. The area in red, again, flooded at high tide under a 1 meter increase. The encyclical was not kidding. We talk about from science to policy. It's hard to quarrel, as the preceding results indicate, with the encyclical's account of the science of climate change. Agreement on every aspect of policy is obviously a little more difficult. In my opinion, on matters related to policy, the encyclical in some passages is a bit too dismissive of the potential of technological approaches to emission reduction. A bit too dismissive, in my opinion, of the usefulness of market-based approaches in driving emission reduction and positive technological change. That's not that market-based approaches in technology are the whole answer, but I think they're an important part of the answer. In some places, the encyclical embraces that. In other places, it seems a little dismissive. It's also, in a few places, I think, a little dismissive of the importance of investing in adaptation to changes in climate that can no longer be avoided. It refers to that at one point as dealing just with the symptoms. It is dealing just with the symptoms, but it's very important, as I will argue, to do so. And finally, not surprisingly, given the teachings of the Church on this subject, I think the encyclical is a little dismissive of the role of the size of the human population in adding to emissions, in making solutions more difficult, and in crowding out the rest of creation. That's a typo. On the other hand, I can happily applaud the encyclical's emphasis on the particular vulnerability of the poor to the impacts of climate change. This is absolutely beyond question. I applaud the encyclical's emphasis on the particular obligation of the rich, both to lead in embracing the needed measures to limit those impacts and to assist the poor, both with mitigation and adaptation. And I applaud the encyclical's call for expanded dialogue, both on fashioning an adequate and equitable global response to the challenge of climate change, and a dialogue on the relation of human society to the rest of creation. What actually are our choices in the policy space? There are really only three choices. Mitigation, the measures we take to reduce the pace and magnitude of the changes in climate caused by human activities. Adaptation, the measures we take to reduce the adverse impacts that result from changes in climate that do occur. And the third choice is suffering. Suffering the adverse impacts and societal disruption that we fail to avoid by either mitigation or adaptation. I suggest that concerning those three, we are already doing some of each. We are mitigating, we are adapting, and as I have indicated, we are suffering already. What's up for grabs, what is open for discussion, is what the future mix of mitigation, adaptation, and suffering will be. And minimizing the amount of suffering in that mix, which of course must be our goal, can only be achieved by doing a lot of mitigation and a lot of adaptation. Mitigation alone can't work because climate change is already occurring, and no matter what we do, we cannot stop it overnight. Adaptation alone won't work because adaptation gets costlier and less effective as the climate changes to which you're trying to adapt get more severe. So we need enough mitigation to avoid unmanageable climate change and enough adaptation to manage unavoidable climate change. Lots of possibilities for adaptation. I list a number of them here. I won't read these to you. You can read faster than I can talk, and my voice is running out. But I will note that many of these adaptation approaches would make sense even if the climate were not changing. It's hard to understand why some of our members of Congress reject even these measures, since they would be sensible things to do, even if climate were not changing or even if humans weren't causing it. Mitigation possibilities. Certainly we will want to reduce emissions of greenhouse gases and soot from the energy sector, certainly reduce deforestation, increase reforestation, afforestation, modify agricultural practices to reduce emissions, build up soil carbon. Conceivably, if we get desperate enough, we might decide to try to scrub greenhouse gases from the atmosphere technologically, basically have the engineered equivalent of a tree, be quite costly, or geoengineering to create cooling effects offsetting greenhouse heating. This is increasingly discussed and almost certainly perilous in terms of the danger of jumping out of the frying pan and into the fire, but it does need to be studied in order to make sure we understand what the perils are before somebody rushes ahead to try to undertake such a thing. The National Academy of Sciences, which recently did a study of these kinds of measures, actually refused to call them geoengineering. And it refused to call them geoengineering because engineering implies a degree of precision which could not logically be applied to these kinds of measures. How much mitigation do we need? Well, I've already noted, as Senator Markey noted, that limiting the average global temperature increase to 2 degrees Celsius, 3.6 degrees Fahrenheit, is considered by many to be the most prudent target that we still might be able to reach. It can be argued that we should have an even lower target, but it's very hard to figure out how we could reach a lower target. European Union embraced that target in 2002, the G8 and the G20 in 2009. To have a better than even chance of staying below 2 degrees C, we would need to stabilize the atmospheric concentration of heat-trapping substances, CO2 and the others, at the equivalent of 450 parts per million of CO2. Doing that requires that the developed countries, the industrialized countries' emissions must peak no later than this year and decline rapidly after that. I'm happy to say that the United States emissions have peaked and are in decline. Developing country emissions must peak no later than 2025 and decline rapidly thereafter. And global emissions in 2050 must be less than half of those in 2005. This is a big challenge. The McKinsey company produced something that is called a mitigation supply curve, looking at the measures that could be used to be on a trajectory consistent with that 450 parts per million stabilization out through 2030. And what is shown here, the height of the bars indicates the cost of the measure. And you see on the left, there are some negative cost measures that actually you make money doing these things, as well as reducing CO2 emissions. And over on the right are the highest cost measures. And the width of each bar indicates how much CO2 emission could be avoided in billions of tons of CO2 equivalent per year by 2030. Now, one can look at that and reach some conclusions about the kinds of policies that are needed to get there. The things that would make money, the question is, why aren't we doing them already? And the answer is, there are a variety of barriers, impediments to picking up this low-hanging fruit, some of which is already on the ground. Impediments like lack of access to financing, lack of information about the available possibilities, distortions in other policies that make it unattractive to do these things. In the middle, you've got some options where it would help enormously if we had a price on carbon to motivate people to reach higher into the tree. The low-hanging fruit is what it already pays to get. If we had a price on carbon, we would reach higher into the tree and grab more of these options. And on the right, the really expensive ones, what we need there is research, development, and demonstration to lower the highest hanging fruit into reach of a modest carbon price. So 3 kinds of policies to address every part of this mitigation supply curve. President Obama's Climate Action Plan, which he released at Georgetown University on June 2013, has all of those aims in mind. Cutting carbon pollution in America is the first pillar, mitigation. Preparing the United States for the impacts of climate change is the second, adaptation. And leading international efforts to address climate change is the third. Just as it underpins the encyclical, science underpins the President's Climate Action Plan. Understanding what climate science is telling us provides the motivation for seeking to develop a cost-effective plan to reduce the impacts of climate change. It provides the sense of urgency for doing so now instead of waiting. It provides the awareness that such a plan needs to include both mitigation and adaptation. It provides the knowledge of the sources of the offending emissions and the character of society's vulnerabilities that allows appropriate specificity in designing the plan. It provides the recognition that any U.S. plan has to include a component designed to bring other countries along. Senator Markey emphasized that as well. And understanding the technological possibilities for both mitigation and adaptation, preparedness and resilience, reveals that there is, in fact, a wide range of options, both for cutting the carbon pollution that is driving climate change and for better preparing society to deal with the changes that materialize. Understanding those technological possibilities enabled the Climate Action Plan to focus on promoting progress on the development and implementation of the options that are, in fact, most promising. And understanding the results of economic assessments of the cost of taking action versus the cost of inaction has made clear that moving ahead now is the right thing to do, because delay would mean bigger damages and costlier action to try to limit the further damages after that. And of course, understanding the results of economic assessments has enabled the Climate Action Plan to focus on the options that are most clearly cost-effective and that bring significant co-benefits, like the reduction of conventional air pollution. A lot of progress has been made. Reducing carbon pollution from power plants, new standards for cutting CO2 both from new power plants and from existing ones, an interagency strategy to reduce methane emissions, a new proposal on controlling hydrofluorocarbons, a 2025 target to reduce methane emissions from the oil and gas sector by 40 to 45%. There's the methane strategy, March 2014. Adaptation, the President directed agencies to support climate preparedness and resilience in a number of ways. One, all federal departments and agencies are now required to develop and implement plans for integrating climate preparedness and resilience into their missions, their policies, their programs, and their grants. Those plans were released in October of last year. The President established both internal and external task forces on resilience. The Interagency Council on Climate Change Preparedness and Resilience, some 30 federal agencies and working groups. I co-chair that with the head of the CEQ, the deputy head of the National Security Council, and the director of the Office of Management and Budget. A state, local, and tribal leaders task force on climate change ended up making 100 recommendations to the administration on how the federal government can be more helpful to states, cities, and tribes in the climate adaptation space. Managing the risks from floods, from droughts, and wildfires, all accentuated by climate change. Whole series of activities and investments. And mobilizing science and data for climate resilience. The Climate Data Initiative, the third U.S. National Climate Assessment, and the U.S. Climate Resilience Toolkit, which provides a web-based access to insights about what communities and businesses and individuals can do to build their resilience and preparedness for climate change. The international dimension, of course, the U.S.-China dimension was already mentioned by Senator Markey. A huge step forward when China and the United States jointly announced in November of last year their new commitments on reducing greenhouse gas emissions after 2020. Mexico, Brazil, India, all following. Multilateral engagement in the G20, in the United Nations, mobilizing clean energy and preparedness finance, extremely important for the industrialized nations to assist the developing countries with their needs. The United States has pledged $3 billion to the Green Climate Fund. The United States, the UK, and Germany developing a global innovation lab for climate finance. So let me talk in closing about the path forward, first in the United States and then internationally. In the United States, we need to defend the requests for clean energy research, development, demonstration, and deployment, and for Earth observation so we can get the data and the information to help people adapt. The proposals for those in the President's FY16 budget are at risk of congressional cuts, and we need to stand up for those increases. We need to finalize the EPA's power plant rules. Again, there will be a congressional assault on those rules. We have to stand up for them. We need to improve the coverage, the usability, and the user base of the Climate Data Initiative and the Resilience Toolkit. And we need to implement the President's Climate Education and Literacy Initiative to ensure that the public will support those other measures. The public needs to understand what is at stake if it is going to support the activities and the investments we need. And of course, we need to elect a president in 2016 who will continue and build on President Obama's climate change program. I, of course, have no idea from which party that president might come, but there we are. The U.S. emission target for 2025, just illustrated here, aiming for 26 to 28% below 2005 levels. There was, by the way, a tremendous amount of analysis behind these numbers. I was involved in it, as was my staff. The path forward internationally. We need to build the public-private global partnership for boosting resilience in developing countries that the President announced at the September 2014 United Nations Climate Summit. We need to continue to push toward a comprehensive, equitable, forward-leaning climate agreement in Paris. And we need to begin to plan for the challenges of the steep declines in global emissions that will be needed after 2030. Most of the discussion to date is about what we have to do up through 2030. That's important, but we need to remember there will need to be an encore after 2030. We need to get ready for it, and to do so in that context, we should create a coalition of major countries and private sector partners who are willing to boost research, development, and demonstration of advanced energy technologies by twofold or more over the next 5 years. This just indicates the kinds of emissions reductions between the business as usual trajectory, which is the top of these bands, and the 2 degrees C emissions trajectory, which is the bottom, the growing magnitude of that difference as we go beyond 2030 into 2040 and to 2050. It's broken down here by sectors: power generation, transport, industry, buildings, and other. Of course, in all of this, leadership is going to matter. Thank you very much.
Your leadership to date and for being here, a very enlightening presentation and many trenchant questions. I can't resist saying, as a former student of chemistry myself, I spent an entire semester doing water chemistry, carbonate chemistry in the physical chemistry lab. At the time, nobody had ever heard of climate change. And now it's, literally speaking, hot stuff. And in fact, I insist that all of my students in my law class on climate law and policy learn those carbonate equilibria, only passively, of course. I'm not expected to reproduce them. We have a number of very interesting questions, but one is you mentioned the IPCC and its relationship to the way the problem is depicted in the Encyclical. There are those who say that the IPCC is something of a consensus process and perhaps is undershooting itself. Not shooting itself, but undershooting in terms of its statement of the urgency of the problem. I was wondering if you could describe a little bit that process, and also to what extent it might, the problem might actually be more severe than that depicted by the IPCC.
Well, first of all, the IPCC is a process that is primarily driven by the engagement of scientists, hundreds, and in fact in the review process, thousands of scientists from around the world who come from a variety of different scientific backgrounds. And they have to come to agreement on what the report is going to say. And so typically, the most cutting-edge stuff is not always going to be obvious to the scientists from every discipline who have to agree on what the report should say. And in that sense, the report is sometimes a little bit behind the cutting edge. And you will notice that each successive report of the IPCC has become more alarming and more alarmist, because it does catch up as the cutting edge stuff becomes thoroughly understood by everybody, and then everybody embraces it. I think the IPCC is a very valuable process. I think it sets, in a sense, the floor on what we know with high confidence about climate change. There are some things we know with somewhat less confidence that we'll probably know with high confidence a little later that the IPCC has not yet embraced. But that's why so many of us across the climate science community are busy looking at the cutting edge and not just back at what the IPCC has agreed that everybody knows.
All right. I tried to divide the questions roughly the way your presentation is organized, namely into first the science and then the policy. A number of very interesting scientific questions. At our current rate of emissions, when are we likely to cross thresholds that trigger rapid feedback loops? How worried should we be about such rapid feedback loops, sometimes called nonlinear changes?
The short answer to the question of when we will encounter some tipping point is that we don't know with any accuracy. There is a sense that going beyond 2 degrees C will lead to rapid increases in the chance of encountering one tipping point or another. But nobody can put a finger with confidence on which tipping point and exactly when. Let me give you a couple examples. There's considerable evidence that a large fraction of the world's coral reefs will not survive a global average temperature increase beyond 2 degrees C. The loss of the world's coral reefs would constitute a tipping point in a number of respects. But we are not confident in that 2 degrees C number. There's a lot of uncertainty about it. There's uncertainty about whether some kinds of corals can adapt better to higher temperatures and acidification than others. Another nasty feedback that people are worried about is associated with the warming of the Arctic, the thawing of permafrost, the exposure of carbon, organic carbon long frozen in the permafrost, to microbial action that would release CO2 and in some cases methane. There is more carbon in the permafrost and tundra soils in the Arctic than in the atmosphere by a factor of about 2. There's twice as much carbon up there as is already in the atmosphere. If it should happen that rapid thawing of the permafrost should lead to a large outflux of that carbon, that would be, again, a tipping point. It would greatly accelerate the pace of climate change. But on current knowledge, it looks like the pace at which that will happen will make it a modest rather than a large addition to what is already happening as a result of burning fossil fuels. The question of feedbacks is a little different than the question of tipping points. The question sort of mixed them together. But we are already experiencing lots of feedbacks. The reason the Arctic is warming twice as fast as the rest of the world is a set of feedbacks, including what's called the snow-ice albedo feedback, where if you reduce the area of ice and snow and it's replaced by dirt and water absorb much more sunlight than ice and snow do. Ice and snow reflect most of it. So that accelerates the heating, which leads to more disappearance of ice and snow in the Arctic, which accelerates the heating further. That is a feedback, and it's already well underway. Another feedback that has been driving the pace of climate change from the beginning of human influence, you put CO2 in the atmosphere, that creates increased trapping of infrared radiation, warms the surface. That means more water evaporates. Water is a very effective greenhouse gas, water vapor. So the water vapor feedback has all along been multiplying the pace of temperature increase around the world. So feedbacks we have already. Tipping points are undoubtedly out there somewhere, but we don't know exactly where. I liken this situation to driving in the fog toward a cliff in a car with bad brakes. And the fog is the uncertainty about exactly where the cliff is, and the bad brakes are the difficulty of changing the world's energy system and forestry practices, which we just do not know how to do fast enough. So the fact that we're doing it in the fog, that you can't put your finger on where the cliff is, does not give me great consolation.
All right, on that cheery note, why do you list solar photovoltaic and CSP as needing further research and development to be achievable?
First of all, there's a big difference between solar photovoltaics and carbon capture, storage, and utilization. Photovoltaics are already economic in many places and many applications, but we can make them more economic, and if we make photovoltaics more economic, they will take over more rapidly from fossil fuels in more places and more applications, and we should be in favor of that and should invest research in getting there. Carbon capture and sequestration, we know how to do it, basically, with some uncertainties about details of some potential sequestration sites in terms of their long-term geologic behavior, but we can't afford it on a large scale. And research and development there is needed. That's a good case of reaching higher into the tree will not be enough unless research and development also lowers the highest hanging fruit.
Okay, another easy question. What is your view about nuclear energy as a component of a future carbon neutral policy for the United States? And then the question specifically asks, what is your view about the potential for using fusion as a new clean energy?
Those are big ones. First of all, the climate challenge would be easier to meet if we had nuclear energy as part of the portfolio. The more options that are carbon-free or close to carbon-free we have, the faster the progress we will make. However, expanding nuclear energy enough to make a significant dent in the climate problem has to confront four major challenges. One, it's currently too expensive and extremely capital intensive. Number two, no solution to managing radioactive waste has yet been accepted politically, even if many scientists and technologists believe, as I do, that we could in fact adequately manage radioactive waste. We've got no scheme in place that has been politically accepted. That has to be solved before nuclear can be expanded. Third, we have to master the challenge of proliferation. We have to be sure we can prevent the spread of nuclear energy from spreading the capability to build nuclear weapons. And fourth, we have to make all nuclear facilities safe not only against accidents, but against malice, against terrorist attacks, against military attacks. Those are four big challenges. And while I think potentially we might be smart enough to solve them all, I would not place a lot of money on nuclear being able to overcome all of those sufficiently to make a large contribution.
All right. This question came up with before Senator Markey. What is the role of methane gas emissions, and particularly the gas pipelines that are planned for New England?
Well, I mentioned in my remarks the methane strategy and the recent goal announced by the EPA of reducing emissions of methane gas from the natural gas distribution system. The evidence we have to date indicates that the principal sources of methane leaks are rather easily fixed technologically as soon as one pays attention. And the good thing about recent discussions is we're starting to pay attention. So I believe that we will succeed in drastically reducing methane emissions from pipes, from distribution centers, from other activities involved with the production and distribution of natural gas. As Senator Markey also said, of course, in the longer run, we will want to transition away from natural gas. But in the shorter run, natural gas is so much better than burning coal that we are going to happily continue to use it for a time. And as long as we do, we will need to reduce those leaks.
Okay. Thank you very much. You mentioned that U.S. carbon dioxide carbon emissions have peaked. Is this due to policy or a response to lower economic productivity?
The economic answer to that, the economist answer to that, is about half and half. That is, a substantial part of the decline in U.S. greenhouse gas emissions was due to the recession. At the same time, it looks like a good half, maybe more, was due to improved fuel economy, improved efficiency in power plants, increased use of renewables, improved efficiency in houses and commercial buildings. We're getting a lot done on the emissions reduction front that is going to matter. And you know, there's a lot of reason to believe that the economy has come back, is coming back, and we're going to continue to reduce greenhouse gas emissions in the face of significant economic growth.
Okay. This is a lot of fun for me. I hope it doesn't make you, but I'm the one asking the question. So if it doesn't make you feel as if it's graduate school orals all over again. But here's another interesting question. Do you see zero waste playing a large role in future climate mitigation policy? And if yes, in what capacity would you foresee it on a national level as opposed to a state level?
Actually, I'm not entirely sure what zero waste means, and I would,
Waste reduction, I suppose.
I mean, waste reduction is a terrific idea. Reducing waste to zero is not physically possible. As a physicist, I occasionally have to remind people about the second law of thermodynamics that says in the energy sphere there is always some loss. You can't make it all useful. And there is nothing to suggest that we are going to overrule the second law of thermodynamics. No exception to it has ever been avoided. I used to tell has ever been observed. I used to tell my classes that the day the second law of thermodynamics is surpassed or overcome will be the day that beer refrigerates itself on the sidewalk on a hot day and squashed cats on the freeway reassemble themselves and trot away. So there will always be waste, but it is worth reducing it. I just realized I didn't answer the second part of an earlier question, which is about fusion. My technical roots were in the fusion field. I'm interested in fusion. I would love to see it work. The history of research in fusion, which is now more than 60 years old, has largely been a history of developing wonderful new schemes for successfully harnessing a fusion plasma and then naming a new instability after what happens when you build it. With that said, there has actually been enormous progress. The rate of improvement in the performance of fusion machines matched for many decades the rate of improvement in semiconductor performance, the famous Moore's law. The difference is that fusion started at such a low base that even after all that improvement, fusion machines still don't break even. That is, it takes more energy to run them than they produce. The best performance in the world from a fusion machine is one that produced about 2/3 as much energy as it took to run it. That's a pretty good performance, but it's still nothing an electric utility is going to buy. And so, in my judgment, having an additional, very long-term, essentially inexhaustible energy source, which could be made much cleaner and safer than fission, would be nice and is worth continuing to spend some money to try to achieve. But I don't have a clear crystal ball that says either that you can do it for sure or that it will happen by a particular time.
All right. Thank you very much for that very thoughtful answer. Let's see. Turning from the basic science to policy. I had a question here misplaced, but I have a question myself about some of what one might describe as some of the more outlandish geoengineering possibilities, such as putting reflectors in space, or what I told my students, there seemed to be proposals to take those little plastic peanuts that you use as packing material and throw them on the ocean. Previously, we were supposed to recycle them. So I was wondering what you see, to what extent you see geoengineering as a potential solution to the global warming problem.
Well, number one, let me be very clear, I do not see it as a solution. There is no single solution. Whether it can contribute to a mix of approaches that will help depends on the kind of approach you're talking about. First of all, let's stop calling it geoengineering and join the Academy in calling it solar radiation management. There is one approach to this which is tried and true and clearly harmless, and that is painting highways and roofs white, okay? So you reflect more solar energy than you would if the highways and the roofs were black or gray or dark brown. That is solar radiation management. It is, in the strict sense of the word, geoengineering. Nobody objects to it. It's being done rather widely, but it is very limited in its impact because the fraction of the Earth's land surface that is either paved or covered with houses is in the range of 2%. Okay? So you're not going to have a huge effect doing that. The more outlandish schemes that you describe, you mentioned putting reflectors in space. The annual meeting of the National Academy of Sciences a few years ago had a presentation from one of our leading space engineers who had calculated what it would cost to put giant Fresnel lenses at the gravitational equilibration point between the Earth and the Sun, where they would stay if you got them up there, to deflect enough solar energy away from the Earth to offset the amount of global warming that had taken place up to that time or was expected by 2020, something like that. And he estimated that the cost of this was $1,400 trillion. $1,400 trillion, roughly 100 times the GDP of the United States at that time. That's clearly not a very attractive proposition. There are some schemes that are getting more serious attention. One of them is injecting sulfate particles into the stratosphere in much the way volcanoes do. When major volcanic eruptions inject a lot of sulfate particles into the stratosphere, the Earth typically cools off for the next 2 to 3 years. We had a cooling in the early 90s because of a big volcanic eruption. And the argument is, if volcanoes do this and the world doesn't end, why can't we do it? Well, there are a number of reasons for that. Volcanoes don't do it continuously. And doing it continuously might, for example, adversely affect the ozone layer that protects us from ultraviolet radiation of particularly destructive kinds. That is now being looked at quite carefully. One of the things that the solar radiation management strategies, of course, do not touch is the dissolution of carbon dioxide in the ocean leading to acidification. So you don't, in any case, even address at all some of the dimensions of global warming. I used to tell my students, taught a course for many years at Berkeley called Quantitative Aspects of Global Environmental Problems. And we would, in that course, learn about the Earth's energy balance and the different kinds of energy flows. And when you do that, you discover that the Earth is a very complicated heat engine, very complicated machine with lots of flows of energy, some in the visible wavelength, some in the infrared wavelength, some in ultraviolet, some stored as the latent heat of vaporization of water you evaporate and then gives it up in the atmosphere. And the notion that by interfering in one of those flows at a particular place, you will offset global interference in a bunch of the flows all over the place is a little bit like thinking if your watch is broken and you stir around inside it with your pencil, you might improve its performance. It's just not a great bet that we can really counteract all that we're doing with the greenhouse gas buildup in the atmosphere by some solar radiation management. Nonetheless, I do agree that these approaches need to be examined, and they need to be examined for two reasons. Number one, we need to understand their shortcomings so that in desperation, a really bad one is not grasped in haste. And number two, it is always worth continuing to look to see whether there's some brilliant idea there that nobody has thought of yet that might actually help. But so far, the approaches that I have seen, other than painting highways and roofs white, generally have liabilities or uncertainties that outweigh their attractions. So far.
All right. Another policy question. This one falls in my discipline in the category of your having opened the door in your presentation. When I was born in 1949, there were about 2.5 billion people living on the Earth. There are now about 3 times as many. How has population growth affected global poverty and our natural environment, and how can population growth best be addressed?
Well, I said very briefly in my prepared remarks that the size of the human population does matter in a number of respects. Number one, if you just look at the arithmetic, the impacts that humans have on the environment is a triple product. The number of people times the resource consumption per person times the impact per unit of resource consumption. The first is a matter of demography, the second is a matter of economics, and the third is a matter of technology. And they all matter. We did a study a few years ago for the Secretary General of the UN. I say we, 18 authors from 11 countries, including China and India, on climate change and development. In fact, the subtitle of that study is one I already used in my talk. The subtitle was Avoiding the Unmanageable and Managing the Unavoidable. And it looked, among other things, at what would be the difference in greenhouse emissions in 2100 if the population then were 8 billion versus 12 billion. And assuming that that difference did not have any impact on the amount of economic growth per person that took place in the meantime. Of course, you can dive into those kinds of assumptions very deeply, but of course, it's a very significant factor. The difference between 12 billion and 8 billion is a big quantitative difference. Now, the question is, should we be doing anything to try to get to 8 rather than 12? And my view about that is it is very well established that providing education and health care and the availability of contraceptives to women around the world reduces birth rates very substantially and increases quality of life in other ways. So it seems to me that that is something that we should be in favor of.
Okay, I think we have time for maybe 2 more questions, and there are a series of questions that I will amalgamate that basically go to what is your job and how do you do it? In particular, how do you represent the president on science policy vis-a-vis, and this is of great interest to me as a former executive branch official, other agencies within the government, EPA, there are a number of questions about EPA policies. How does the president and you on his behalf interact with agencies that have specific sectoral responsibilities? And then the other set of questions deals with how do you interact with members of Congress, and in particular those that might be, say, more skeptical than not on with respect to climate?
All right, let me start with the interactions with the departments and agencies. There is a tremendous amount of scientific and technical talent across the departments and agencies of the federal government. We've got EPA, the Department of Agriculture, the National Science Foundation, the Department of Energy, the Department of Defense, the Department of Health and Human Services, Department of Interior, all have huge operations. I have a small operation. I have a little more than 100 people in OSTP. But our responsibility is, number one, to make sure that the president and his other senior advisors know everything they need to know about the insights relating to science, technology, and science and technology programs of the federal government that are available across all those departments and agencies. So we reach out. We have to be in constant touch with the scientists and the engineers and the managers across all those departments and agencies to make sure there's nothing happening there that we don't know about and therefore the president doesn't know about that he might need to know about. Secondly, we work very closely with the OMB, the Office of Management and Budget, in developing proposals for the president about the science and technology budgets of all those departments and agencies. That is, the president's proposals in his annual budget, most recently the FY16 budget, specify how much money is going to go to R&D at the NIH, at the DOE, at the DOD. The fact that my office has such a big role in working out those budgets ensures that they always answer my phone calls when I call them up for help and say, what's going on over there that the president might need to know about? They always answer my phone calls. So we have good relations with those departments and agencies. And the Congress can be a little more challenging. I testify before Congress from time to time at their invitation. I've testified about climate change before Congress on a number of occasions. I tell them what I believe to be the case. We sometimes have very interesting Q&A following that testimony. 10 minutes of one of those Q&As appeared on The Daily Show with Jon Stewart. Mr. Stewart found it so entertaining.
Certainly your contribution.
But it's... No, it can be a challenge. It's an interesting fact as revealed in polls that about twice as many members of the American public believe climate change is real and substantially caused by humans as members of the Congress who say they believe that. So I think to the extent that a substantial faction in Congress disputes the basic reality of climate change, the human role in it, and the need to do something about it, I think they're out of touch with the American people. And I have to assume that if our democracy works, eventually that gap will be closed. I better quit while I'm ahead.
Well, that's a hard one to follow, but I think I'm going to exercise the prerogative of the moderator and ask the last question myself, which is a topic that you mentioned in your presentation toward the end. One of the principles about the Paris outcome is supposed, according to the United Nations, is its durability. And both you and Senator Markey, impliedly we're talking about the policies that the president put in place relying on his own executive authority as delegated to him by the Congress. If that's the case, how durable are those actions, both on the domestic level and on the international level? At least in the circles that I move in, there's some concern about the U.S. 26 to 28% reduction goal for 2025 being a non-binding target as opposed to something that's binding in international law. But so the question operates on two levels: durable both in international terms on the international level as well as on the domestic level, so that when we have, contrary to your hopes and expectations, a president who maybe is less receptive to these issues is elected next time, those policies will survive this president's tenure.
Well, that's a very tough question, obviously. First of all, it is our judgment that the 26 to 28% can and will be achieved if the policies the president has put in place up until now are continued, if they are maintained. If they are not, we will not make that target. It's very simple. I mean, that part of the answer is simple. If we do not maintain these policies, if the clean power rule is thrown out, that alone would prevent us from reaching that target. So those are targets that can be reached with executive action only. They assume no further assistance from Congress, other than Congress refraining from doing something that would successfully gut those provisions. But none of the targets that anybody has announced are binding in the sense that there will be a penalty other than disapproval and dismay for failing to meet them. That is, there's no court that is going to take the United States to task for failing to meet 26 to 28%. There's no court that's going to take China to task for failing to peak their emissions by around 2030. But my view is that the court of world opinion is going to be very powerful in this respect. And it's going to be powerful in part, unfortunately, because the symptoms of climate change are going to continue to get worse. People are going to notice more and more all around them more heat waves, more extremely powerful storms, more extreme downpours and floods and mudslides, more wildfires. I mean, just the wildfires, that's another sleeper. You look at the extent to which the average annual area burned in the United States has increased over the last 30 or 40 years. It's like sixfold, and that is projected to continue. People are noticing, and they are going to continue to demand action from their leaders, and failure to meet these kinds of targets, I think, is going to carry a heavy political price, and that's going to be true in China as well as in the United States. So again, I thank you all for your attention.